Hi, I'm Rosalie Nelson. Welcome back. In the previous section, we were looking at the changes within the New Zealand market and some of the challenges and how the ultra-fast broadband project will influence that. But before we go on, we felt this was an ideal opportunity to go back and look at some of the first principles of telecommunications network, try and find our way through the acronym soup. If you were to listen to the media talking about fibre, it's almost like it's a Big Bang theory. Copper is dead, it's old, it's a veteran technology. Fibre is the way of the future. Of course, the reality is somewhat more complex, and it's worth actually remembering what copper and fibre can actually do. The first thing with copper is that it carries voice and data via electrical signals. The copper loop, or the last mile, is just quite simply the connection between your premises at your home or your business back to the first telecommunications exchange. Now, the real benefits of copper is that it is ubiquitous. Almost every home and business has a copper connection, and it is very robust. It carries very high quality voice signals. At the same time, it is also adaptable. We are seeing continuing evolution in copper capability. It's not dead and over yet. Fibre optics, by contrast, is a very different technology. Data signals are sent via light waves over a glass strand, which is the fibre optic cable. Now, fibre comprises the core of all modern telecommunications network, and it has the advantage in that it is future-proof. You can keep upgrading its capability to carry almost unlimited amounts of traffic. It also has the benefit of being symmetrical. You can get the same amount of traffic going down fibre cable as well as going up. Now, we hear a lot of talk about these different concepts of dark fibre and lit fibre. Dark fibre is just simply the fibre strand in its passive or inert state. If you were to think of it as you would an electric rail network, the dark fibre is a little bit like the rail tracks. You can lay them and they show the path that comprises the network, but nothing can run over it until you actually have the electronics in place. So it is with a fibre optic network. Lit fibre is when you've put in the transmission electronics so that the services can run and data can be carried. It is also worth remembering that fibre is at the core of all modern telecommunications networks, and where the debate is now is around the access network, that last mile link between someone's home or business back to an exchange. Now, fibre supports a wide range of different technologies here. In this slide, we can see the way in which copper can connect from a local exchange to a home or a business. Now, when we start talking about unbundling of the local loop, that is when carriers put their own equipment into a local exchange and effectively lease that copper link from telecom to run their own services over it. However, one of the challenges with copper is that the distance or the speed of the data that it can carry weakens over distance. And this is where cabinetization becomes very important. What telecom is doing with cabinetization is extending the closeness of the fibre towards the home so that the copper loop becomes much shorter and therefore can carry data at a higher speed. Fibre is also very important for cell towers with mobile broadband. Effectively, these days we're moving away from just voice and text and using data over the mobile networks, but data requires very big fat pipes away from the cell sites. And then, of course, you can have fibre direct to the home or even cable to the home, as Telstra has in Wellington and in Christchurch. So the access network gathers the traffic and the connections from the homes to one first exchange point. But then from there we have the backhaul network, and that aggregates all the traffic and connections from exchanges within a suburb or a geography and takes it back to the core or the trunk network. Now, the trunk network are the very big pipes that run between Dunedin and Christchurch, Wellington and Auckland. It carries all the traffic up to Auckland, where it then jumps off onto the Southern Cross cable internationally and often up to the US. So what we can see with this is upgrading broadband access really is not enough. You can compare a telecommunications network to a road network. And the time to complete your journey on a road network is going to depend on a number of things. The first is your car's equipment, age and state of repair. The reality is that for a lot of us, our homes are quite old and they may have old wiring, or we may be using old computers within the home, and that's going to affect your broadband experience. The second is the quality and the length of your drive and your local street, the distance that you actually have to travel to get down to a primary or a main road. Now, that's the equivalent of your access network. But then, of course, you have to think about the congestion that's on your primary and secondary roads and how that's affected by things like rush hour or roadworks or after-school traffic. Have your primary and secondary roads been upgraded to cope with all the traffic and the increase in infrastructure and usage? Then you have the capacity and the availability of the motorways. And then once you get to your destination, can it actually handle your arrival? Is there the car parking? Now that really equates to how many customers, for example, a server in the US can actually support. So as you can see, we need to think very holistically about what comprises the broadband experience if we're really going to deliver ultra-fast broadband. This is why internationally we're seeing a number of countries that are utilising the ubiquity of copper with the capability of fibre. In other words, taking fibre to the most economic point. Now, IDC internationally forecasts what we describe as next generation access connections. These are the ultra-fast broadband connections using the new technologies. And we're forecasting this will rise from 2% to 21% of total Western European connections by 2012. But the interesting point here is that if you break that down, the majority of those next generation connections are based on VDSL, copper plus fibre. And this is exactly the type of copper technology that is being utilised here in New Zealand today through cabinetisation. In other words, we're already on the road. Now, it's all very well to talk about technological capability, but how much speed do we actually need? Well, the reality is that if we really want to utilise fibre to the home, then we need to be delivering multiple streams of high-definition television to multiple devices. And the reality is that we simply don't have those kinds of services available here in New Zealand as yet. So we can do broadcast TV over broadband at 10 to 25 megabits per second. We can do video streaming on demand, telemedicine, and quality home video conferencing at 20 to 35 megabits per second. So when we're getting up to 100 megabits per second, which is the fibre capability, that's when we can do interactive e-learning or, for example, 3D gaming. Now, these may be very attractive, but those services are not really available yet, certainly not in the mass market. So this is something that IDC believes the government really needs to address. So what all of this means is that improving broadband access in itself is not enough. When we're thinking about ultra-fast broadband, we need to address the cost and capability available on all of the network links. We also need to keep in mind that copper-based broadband is continuing to evolve, that combined with fibre, it can deliver speeds of up to 100 megabits per second. And we need to think about, if we're going towards a fibre future, how we can migrate from copper to fibre. Fibre is future-proof, but it is costly. So we also need to think about how we can economically begin to deliver fibre in New Zealand. And we also need to go back to the first principle, that the user experience for you and I when we're using broadband is going to be based on multiple factors. Home wiring, the equipment, and where we live can all have a big impact on our broadband experience.